candidates test.
Oh, yeah.
CT
Sad.
means candidates test.
Feels bad. Oh my god.
So 0, 2, 5. Oh, darn it. Who's gonna be on the darn video? 1, 2, 3, 4, 5.
I got 1 point.
0, 2, 5, 7, 8. 0, 4, 13. Some of you are giving too much information, and then you're making a mistake, and then you're losing a point. Do not ever give units unless they ask for it. Because some of you gave units, and it's wrong units. They're going to take away a point. Use the data in the table to approximate the rate, which is slope, in hundreds. See, and they actually give you the units right there, in hundreds of entries per hour. You don't need to give units. They're giving it to you. So unless they ask, do not give units. At which the entries are being deposited at time t equals 6. Show the computations that lead to your answer. Now this is worth 1 point. Now 6 is not on the chart, so you have to use the 2 points that immediately surround it. So simply find the slope between these two. Like here, look. Y minus y over x minus x, 1 point, just leave it. Do not simplify it. That's it. That's what they want. They want to see a slope formula. Y minus y over x minus x. B. This one is worth 3 points. Using a trapezoidal sum with 4 subintervals given by the table, approximate the value of 1/8 integral 0 to 8 e of t dt. Okay, so 1/8. Now, how do you approximate the area or the integral from 0 to 8? Using trapezoids, you use the trapezoid formula, right? So 1/2, how far is it from 0 to 2? 2, or you can put 2 minus 0 if you want. And then b1 plus b2. Next trapezoid, 1/2 the height, how far is it from 2 to 5? 3, and then you just go b1 plus b2. 1/2, how far is it from 5 to 7? It's 2, or you can simply put 7 minus 5 if you want. b1 plus b2. And then let's finish it off here. 1/2, how far is it from 7 to 8? 1, and then you go b1 plus b2. Right there, 1 point. Ka-ching! Using correct units, so now they want units, so that units is going to be 1 point. Explain the meaning of this integral. Well, this is 1 over b minus a, right? So this is the average of whatever this is. When you compute an average value, you're finding the average value of whatever that is. So it's the average. Now, some of you can write average value if you want, but just say whatever this is. What is E of t? What does it say right there? The number of entries in the box. So the average number of entries in the box, I think that part is optional, in the box from t equals 0 to t equal 8 in, and what kind of units it's going to be? Hundreds of entries, right? In hundreds of entries. Because if somebody were to ask you what is the average number of entries, you would just say, oh, so and so. Like, now some of you actually computed this number. You're taking a risk if you do. So if you're going to do it correctly, like some of you punched it in on your calculator, this is what you should get, 10.688. But why? This is the exact answer. That's good enough. You don't need this. So do not volunteer extra information, because if it's wrong, you're going to get a whole point taken off. And this problem is only worth 3 points. Okay, next one. C. At 8 p.m., volunteers begin to process the entries. They process the entries at a rate modeled Okay, so if you just wrote that down, you're gonna get 1 point, because now what you do is some people actually took the antiderivative and plugged it in the numbers, and you can. But since you have a calculator, just do the darn thing on your calculator. Anyway, if you compute this, what does it come out to?
16.
It came out like really nice, 16. So the question is asking, how many entries have not yet been processed? Well, how many entries were in the mailbox at the end? 2,300, right? This is how many were processed, so how many were not processed? Well, the answer is 23 minus 16, which is 7. So what is the answer? 700, or if you want to write 700. Because remember, these are in hundreds of entries, yeah? I think it's easier just to write this. This is your answer. Actually, you could just write this. This is your answer. 23 minus 16. Question?
So I got a point off for writing 700 entries.
What happened?
I did 23 minus 16. I did that one, right?
Oh yeah, I don't know why. Okay, that should be a +1.
Yeah.
I'm not sure why you marked that wrong. And then finally, 3D. According to the model for part C, at what time were entries being processed the most quickly? Okay, so we want to find when was the entries produced the most quickly. So this is the rate at which the entries were being processed. What do we want to find? Don't we want to find the maximum value of this then, right? Because this is the rate at which they process. So the rate, we want to find the biggest rate, the maximum rate. So, and of course that means absolute maximum. So, how do you do this? You take the derivative so we can find the critical points. So this is 3t squared. Because how do you find maximums and minimums? You take the derivative and make a number line, right? Now, this is too ugly. I mean, you can use the quadratic formula, but you got your calculator. Just graph this on your calculator. It should look like this. Calculate when it's 0. So this point here is 9.184. I did it with my calculator, 10.817. So if you were to make a number line for this, you would have 9.184, 10.817, and it's going to be above, below, above. So plus, minus, plus. Increasing, decreasing, increasing. Now actually, since we're going to do the candidates test, you don't even have to put this increasing, decreasing, increasing thing. Because the candidates test is what they want. So here's T, here's P of T. What do I need to put in this candidates test? Well, you need to put the critical points and the endpoints. So you need to have 8, 9.184, 10.817, and 12. Then you take each of these numbers. Now remember, when you plug it in, you got to use all the decimal places. Now, do not just use these 3. You take all of these numbers and plug it into here. And if you do it correctly, you should get 0, 5.089, 2.911, and 8. Well, of course, that one should be 0, right? Because right at that time, you didn't process any yet. So we want to find the biggest. Which of these is the biggest number? Right there. This is the absolute maximum. But answer the question. It says, according to the model, at what time? So you could say 2 things. You could say at t equal 12, or what does t equal 12 represent?
Midnight.
Or yeah, you could put midnight. I think that's easier, at t equal 12.
Wait, did I not get any points for my justification was that I wrote T equals 12 because I graphed it.
That's because
I knew it was T equals 12 though, because I graphed the.
you graphed this on your calculator,
Yeah.
and that was the highest point. See, but that's not what they want you to do. They want you to do the analysis. This is what
You
gets
don't
the
get a
points.
point for the answer.
But then it doesn't. be in a table with t versus p prime. It should be t versus p.
No, yeah, I was just wondering if we get any.
Oh, no, you don't get it, no, because it's,
It's just guessing.
yeah, exactly.
Well, I knew what the answer was. Didn't know how to
See,
shape it.
again, no sense argue with these people, you know. Just do what they want.
Wait, so what are the 3 points distributed for?
Candidates.
Say that again?
What are the 3 points distributed for?
Okay, the first point is you identify the critical points. Did you get these 2 points? Oh, okay. And then the next point is the candidates test, and then the answer.
Yeah, that's what I was wondering.
No, but see, you don't, just because you get the answer, if you don't support it, you don't get the point.
Any point? Okay.
Yeah. So a lot of lessons to be learned here. Do not give units unless they ask for it, because if it's wrong, bam, point gone. Do not simplify anything. So don't even do this 10.688. Just leave it like that. Okay, luckily the AP exam is not tomorrow, because then we'd be in trouble. We have 3 weeks from today. Okay, so tomorrow's quiz is not, I'm not gonna see you tomorrow. Thursday's quiz is gonna be what? What was last night's homework? The rate. Do we have any problems with that? So I'm assuming everybody read the email, yeah? So here, in show B, I made a separate folder for each one, because I was looking through it this morning, I'm going, oh my God, some people didn't even do the multiple choice Friday night's homework.
Wait, so we have to turn it back in?
Yeah, put it back in here.
Oh,
Just gotta press some buttons, huh?
Huh?
we have to resubmit it from Street.
Is there a way I can grab it, put it in here?
I don't think so.
I don't think so.
You
Yeah,
could just make a copy.
That's okay, you guys got the Friday to do it. You can do it while you're in the bathroom or something.
Let's do it right now.
Alright, now tonight's one, I'll tell you right now, the ones the students have the hardest time with every single year is the graph and the rate. These two. So I remember last year, I had to give like the same quiz 4 times. Not the exact same quiz. Like, I forget if it was the graph or the rate problem. Until we finally got it. But we'll do whatever we have to. That's why if you look at the assignment sheet, the quiz has a question mark. I'm not sure which one I'm going to give you. All right. So any questions on last night's one? Okay, here. Look at number 1A on 2013. See how they give you a function? And then they ask you, find g prime of 5. That means take the derivative and plug in 5. Can everybody do that on your calculator without actually taking the derivative? Remember how to do that? Let's review that.
Derivative function.
So one way to get the point is you can actually take the derivative and plug in 5, and you'll get the point. Or you can just have your calculator do it. Okay, so here, this is 2013, number 1. Here's the function. Number 1 means you get to use a calculator. 45 cosine t squared over 18. Because if you take the derivative wrong, then you're in trouble, yeah? So compute g prime of 5. So one way is take the derivative. So the derivative of 90 is 0. Throw the constant on the side. And what's the derivative of cosine box? Negative sine box times the derivative of box, which would be 1/18, throw it on the side, times 2t. And then they want you to plug in 5, and you don't have to simplify anything, so you can just do this. Sine of 5 squared over 18 times 1/18 times 2 times 5. Good enough. You don't even have to punch that in on your calculator. So you can either give the exact answer, or you can punch it in and give 3 decimal places. Now, using correct units, interpret your answer. So like I told you before, anytime they ask you for the derivative, that is the rate at which the function is changing. all you have to do is this. This is the rate at which G is changing at t equal 5. But then I told you guys, substitute what it says G is right there. Because they want it in the context of the problem. So what is G?
The rate at which unprocessed gravel arrives.
The rate in which the unprocessed gravel arrives. So then just put this in which the rate at which unprocessed,
The rate of the rate.
at which unprocessed gravel arrives. Like that. You know what I mean? See, so this is like an easy way. No matter what it is, you just say it's the rate at which this function is changing at t equal whatever, and then you go back and then you just substitute whatever the meaning of the words are for that function. Yeah.
Oh, sorry. From 2015,
For which one?
2015 B.
Okay, wait. I'm not sure if we're done with that one. Oh, and right here. What is the maximum amount of unprocessed gravel? That's the candidate's test right there. Anytime they ask you to find a maximum or a minimum. Okay, 2016.
15
Oh, 15.
B.
Which one?
B.
B.
I was wondering why it's like we do R on D of 3 instead of like the integral from 0 to 3.
Okay, because if they're asking, is the amount of water in the pipe increasing or decreasing, you have to look at the derivative. If the derivative is positive, then it's increasing. If the derivative is negative, then it's decreasing. So what you have to do is take the derivative and plug in 3.
But they just plugged in 3 to the normal equation.
No, they plugged in 3 into the derivative.
Right?
Here, I'll show you.
Which one is this?
The B.
Oh, which one?
Okay, what is the original equation? The amount of water. Okay, is this the one we did yesterday? What is the amount of water in the pipe? What did it start with? I forget already.
30 plus
30. And then how much water went into the pipe? The
the
integral
integral
of
0 to x.
r of t dt from 0 to t, right? And then water got taken out of the pipe. How much water got taken out of the pipe? It's the integral of d of t dt from 0 to t. This is the amount of water in the pipe. So how do you find out if the amount of water in the pipe is increasing or decreasing? You look at its derivative. So how do you take the derivative of this? Well, that's 0. How do you take the derivative of integral? Make sure that's a constant. Take the t and plug it in, times 1. And then same thing here. Take the t and plug it in, times 1. This is the derivative. So what you do is you plug in 3. If this number is positive, then it's increasing. If this number is negative, then it's decreasing.
Okay.
Yeah.
Thank you.
Question?
Can you go over 2014 D?
2014 B. D. Okay, I gotta read this. Grass clippings are placed in the bin. The amount of grass clippings remaining in the bin is modeled by the function. And A is in pounds, okay? When t is greater than 30, the linear approximation to A at 30 is a better model for the amount of grass remaining in the bin. Use L of t to predict the time at which there will be 0.5 pounds of grass remaining in the bin. So did you have to write the linear approximation?
No, what is
That's like the tangent line. Linearization. But see, AP exam, they don't use the word linearization like our book uses. Linear approximation means tangent line. So what you need to do is write the equation of the tangent line. I'm going to erase this. Okay, so A of t, the amount of grass in the bin, remember how to do that?
Yeah.
Okay, so if you're gonna write the equation of the tangent line, you need a point, so 30. How do you figure out the y coordinate?
Plug it in.
Plug it in here. So you have your calculator, just plug in 30 for t. I don't know, what does that number come out to? You guys have the thing, don't you guys have the scoring guidelines there? Or I can get my calculator and punch it in.
Wait, what is this? Eight? Wait, prime? Wait.
No, just 8.
0.783.
Okay. And then you need the slope. How do you find the slope? Well, you can take the derivative of this and plug in 30. In fact, why don't we practice? This is a good drill. Okay, you throw the constant on the side like an unwanted pet. How do you take the derivative of a to the u? So a to the u, so 0.3931 to the t times natural log of this of 0.931 times the derivative of that, which is 1. And then all you have to do is plug in 30 and then punch it in on your calculator. Or you can just have your calculator compute the derivative for you. So you remember how to do that?
Yeah.
Okay, so what you do is you go to the template button. So if you're in the home screen, you can just go dbox, right? So you want to take the derivative of, I guess you could punch in 6.687, 0.931 raised to the x power, and then you put x equals 30 there, and the thing will just go, and it'll take the derivative for you and plug in 30. So like, if you don't trust yourself in computing the derivative, then just do this. Your calculator will do it for you. Anyway, what number did this come up to?
I have no clue.
Angela, you got it?
Oh, sorry. The final one?
A prime.
Oh, sorry. Negative 0.056.
Okay, so assuming this is correct, well, that's the slope. So negative 0.056. So if you got a point in the slope, how do you write the equation of the tangent line? You go y minus 0.783 is equal to the slope, which is negative 0.056 times x minus 30. And when we do linearization, what do? We move this on the other side. So y equals 0.783 minus 0.056 times x minus 30. You guys remember doing that? Yeah, but the AP exam is not going to call it linearization. They're going to say linear approximation or use the tangent line, something like that. Now, they said use this to predict the time when there will be 0.5 pounds of grass clippings in the bin. So, we're using y to approximate the amount of grass clippings. Because here, this is the whole concept of linearization. When you have a curve, when you make the tangent line, the point on the line, if you are close to this point, the point on this line is very close to the point on the actual curve. But working with a line is like the easiest function to work with, right? So we want to know when the amount A will be 0.5. And of course, this is an approximation for A. So what you do is you just simply plug in 0.5 for y there. And they just want you to write the equation, right? No, they want you to actually compute it. So they actually want you to solve it then. So all you have to do is solve for x, which is the time, right? And there you go. So you have your calculator. I'm assuming everybody can solve for x here, or t. It should be t, but you don't really care if it's t or x. We'll take either. You guys understand that? So tangent line. Okay, we only got 10 minutes left. We're going to discuss tonight's one. Now this one is pretty easy. We want to score high on this one. This is the slope field and the differential equation. In fact, here, let's do number 6 together. I think we can do this in 10 minutes. So for the have to draw a solution curve, or they're gonna give you some points, and then you gotta like draw the slope. So this is 2014, number 6, which is no calculator. Here is your differential equation. dy dx equals 3 minus y times cosine x. Okay, so if they give you, like for example, okay, let me think. Maybe they might give you something like this. At this point, draw the slope field. Like at the indicated points, usually they might give you 4, 5, or 6 points. Okay, but I'll just do one. This is the point 0, 2. What happens if I plug in 0 for x and 2 for y? You would get dy dx equals 3 minus 2 times cosine of 0, which is 1. So what you do is, through that point, you draw a hash mark that has a slope of 1. And like I told you when we did this before, all you have to know is a slope of 1 makes a 45-degree angle. Anything bigger than 1, like 2, 3, 1.5, or 4, as long as it's steeper than 45 degrees, you're going to get the point. You know what I'm talking about? Okay, what about down here? No, I mean up here. What about at the point 0, 5? What happens when you plug that in? dy dx is equal to 3 minus 5 times cosine 0. What is that? That's negative 2. So you make a hash mark that has a slope of negative 2. So as long as it's negative going downhill and it's steeper than negative 1, then you'll get the point. Okay, but in this problem, they gave you an entire slope field. They want you to draw a solution curve through the point 0, 1. There, let me do it on the board so whoever's watching the video. So you have to look at that slope field. So here's 0, 1, and then you just follow the slopes. So let me look. It's going to go up, flatten up, and come down. So it's going to look something like this. On this side, and then on the other side, it's going to go down, flatten out, and then come up. So it's going to be something like this. And like I told you before, if you want to get whatever points they assign to this, you got to go all the way to the end of the slope field now. Like if this is the end of the slope field and you stop, you're going to lose a point. They want you to go all the way to the end. Same thing on this side, go all the way to the end. Do not stop short. Okay, B, write the equation of the tangent line at the point 0, 1. I'm going to just do it on this side. So at the point 0, 1, how do you write the equation of the tangent line? Well, we already got the point, we just need the slope. Well, doesn't the derivative tell you the slope? So just here's the derivative, plug in this, what do you get? 3 minus 1 times cosine 0. What does that come on? 2. So the slope is 2. And so point slope form, y minus 1 equal 2 times x minus 0. And is that it? Use the equation to approximate f of point 2. So again, solve for y, move the 1 on this side like we always do. You want to leave the x minus 0, that's perfectly fine. So instead of plugging 0.2 into the original function, which we don't even know, you simply plug it in here. So all they want to see you doing is plugging in 0.2 for x. That's what they want to see. So you get 1 point for writing the equation of the line, and they don't care if it's this or this. And then they want to see you plugging in 0.2 for x right there. That's the 2 points right there. And then sometimes they're going to ask you, is this an over or an under estimate? You guys remember how to tell? You got to look at the concavity. So what you would have to do is you would have to take the second derivative, which is very difficult in this problem. And then, anyway, so at this point, whatever this point is, if the second derivative comes out positive, that means the graph is concave up. And what does that mean? The point on the line is below the curve, so you have an underestimate. If the second derivative at this point is negative, then the graph is concave down. And then when you make the tangent line, see how the point on the line is above the point on the curve? then you have an overestimate. So they might ask you that question too, but not on this problem. And then the most important part of the problem is part C. Find the particular solution. That means to actually solve it. Usually it's worth 5 or 6 points. In this one, it looks like it's only going to be 5 points. Okay, so how do you solve a differential equation? Okay, we got 4 minutes to do it. What's the first step? Just by doing the first step, no calculus involved, you get 1 point.
Get it.
Separate the variables. Put all the y's on the left with the dy, so divide it on this side. And put all the x's on the right with the dx. So multiply the dx on that side. Just by doing this, you get 1 point.
9.
That's pretty good, yeah, for 1 point. But that's not, we don't want 1 point. We want to get all 5 points here. Okay, what's the next step to solve a differential equation after you separate the variables? Integrate both sides. You're going to get 1 point for the correct antiderivative on each side.
Negative ln 3 minus
Okay, negative natural log absolute value 3 minus y. Now, first of all, why is there a negative there?
Negative.
Because the derivative of the box is negative 1, so you gotta adjust for it, right? So if you don't put that negative sign, you're gonna lose the 1 point for that. What's the antiderivative of cosine x? Sine x, and then they both have a plus c. We mush the 2 c's together on one side like this. Now, if you don't put a plus c there, you're gonna lose whatever points you have left. You can't gain any more points. So you have to put the plus c there. Now, how do I figure out the value of the c? You plug in the initial condition, which I'm assuming is 0, 1. So if I plug in 0 for x and 1 for y, you're going to get negative natural log 2, absolute value of 2, which is 2, equals sine of 0 plus c. Now, you should know sine of 0 is 0, but they don't even care. You can leave sine 0, you know. Anyway, what is c then? C is equal to negative natural log 2 minus 0. But if you want to, like if you don't want to risk it, you can just put negative natural log 2 minus sine 0. It's kind of weak, but you get the points. All right, so what do we have so far? Negative natural log absolute value of 3 minus y is equal to sine x minus natural log 2. Now, how do you handle this absolute value? How does absolute value work? If the inside is positive, you leave it alone. If the inside is negative, you negate it. Now, how do you tell? Because you're going to have to pick one or the other. How do you tell if the inside is positive or negative? You look at the initial condition. I erased it, 0, 1. What number did we plug in for y? 1. Is 3 minus 1 positive or negative? It's positive, so you just leave it alone. However, if the point was like 0, 5, then what is 3 minus 5? It's negative. So what you would have to do is negate it. What's the opposite of 3 minus y? Negative 3 plus y. So to get rid of an absolute value, you're either going to leave it alone or negate it. How do you tell? You plug in the initial condition.
You have to get rid of the absolute.
Yes. Yes. Otherwise, you're not going to be able to solve for y. Okay, we got 1 minute left. Now, the last point. Can you solve for y? You just do algebra and solve for y. I hope so. Let's see. How do I get rid of this minus sign? Multiply both sides by negative 1. So negative sine x plus natural log 2. You're just doing that. So 2 of the steps, you're going to get points just by doing algebra. How do I get rid of an ln? You e both sides. E to the natural log gorilla is gorilla. And then finally, how do you solve for y? If I were me, I would put the y on this side and bring this one on this side. It's up to you. Whatever works for you. And you can actually leave your answer like this. However, if this is a multiple choice problem, I guarantee you, it's going to be written like this, you know. How is this the same thing as that? Remember? Because that's the same thing as e to the negative sine x times e to the natural log 2, right? Because Alright, we just barely made it. This part is very mechanical. Usually we don't have a problem on this one.
I have a problem.
We have a problem.
I need to know my weight. I remember I got this wrong and
Oh my god.
You gotta follow the slope. See how the slope goes up and then down.
All the more.
No, instead of follow the slope, like this, and it starts flattening out. So it does go. So if I remember when they graded this, they said you have to make it go below the x-axis. Because if you look at the thing, it has to come below the x-axis.
Do I stop recording?
No, you can't be exact. But then you should know it doesn't go all the way down there, right? Yeah.
Mr. Park, do I stop recording?
Okay, now do it.